This counting techniques is actually a very long section. Now, before I move forward, I would like you to realize that starting from this topic here, I already have the recording from my previous semester. Let me share with you. We already have the recording from previous semester. I want you to see the relation. Go to module. Go to modules. Where's my modules? Here. Huh? Oh, I really thought I shared it. Hey, hold on. I really thought I shared it. Wait. Hey, where did I put it? Give me a second. Hold on. I really thought I did it already. Oh, I put it on pages. Oh, sorry. Yeah, I put it on pages. I thought I put it on modules. I put it on pages. So for the lesson today and I think tomorrow, you can watch go to pages 5.5, 5.6, and it relates to my stats class at East LA College. You can watch the lecture video from there. Of course, in this class, for our class, I will still do the lecture, okay? But I try to make it shorter so that we have more time for examples, okay? And hopefully we can get it faster because for our class at West LA College, we have department finals and I need to cover more material, like one chapter more than the one I cover at East LA College, okay? And this 5.5, 5.6 happens to be on the harder side. So I really hope you can watch the lecture video in advance, okay? Like today we do 5.5, 5.5, and after the class, let's say you watch the lecture video and then do suggested homework, okay? Tomorrow I will do 5.6. Okay, and then on Thursday, I will do 6.1, 6.2. Okay, so 6.11, 6.2 on Thursday. The lecture video for them, their class is actually 4 hours class. So one video that you see there will relate to basically 2 days for us. Well, it depends. You need to see how long is the video. Yeah, it is possible the video is only 1 hour something because they have a test. Well, anyway, let's come back to ours. That's just a reference for you that you can study from my past videos also. Now, for us, we will first do notation. This is a big portion. Notation. First notation that you need to learn is factorial. And factorial means n times n minus 1 times n minus 2 all the way to 3 to 1. So for example, If I have 4 factorial, it means 4 times 3 times 2 times 1, okay, which is 24. 5 factorial means 5 times 4 times 3 times 2 times 1, which when we use our calculator is 120. Now the thing is, what happens if the number gets larger? Let's say if we have 8 factorial. If we have 8 factorial, that's harder to compute, right? Harder to compute. This is hard to compute by hand. But you can. This is hard to compute by hand. The larger the number. So I will teach you how to use calculator here. Okay, now the way we use calculator, this is my notation for calculator. You use your calculator now, you punch 8, and then go to math, PRB factorial. And then enter, I think you need to press enter twice. Enter, enter. Let's see, 8 factorial. Is this on the, yes, it's on calculator view. 8 factorial, so you press 8 and then go to math here. The left-hand column, the third from the top, math, and then you have the option, math, numerical, complex, probability. Now you move the cursor to PRB. And then choose option number 4. You can press 4 right away here, or you can move your cursor. Okay, so that's the first enter. The second enter will give us the answer. 40,320. 40,300. Okay, so 8 factorial is 40,320. Okay, now I hope some of you following me. So let me ask you to try, 10 factorial using your calculator, and then 12 factorial. What do you get? I get, for 10 factorial, I get 3,628,000. 3,628,800. I use comma there just to help us see the big number. Oh, that's a big number. Okay, and then 12 factorial will be, let me show you how I use my calculator. Let me show you how I use my calculator. 12 and then math, BRB so 479 million 1,600. Okay, so the answer I get from Lydia too. Yes, that's right. Okay, I'm glad at least I have you, Lydia. Okay, let's go back to the notes. Now, how to use this factorial, that's something else, okay? At least now, we learn how to use calculator to complete our factorial. And of course, for smaller numbers like these, I hope you know how to do it by hand. Now, please be aware that this kind of thing here, like how to use calculator, is another crucial skill in this class, though, in this class. Why? Because in my on-campus class where students came to class at that time, during their quiz or their tests, some of them, not all, but some of them, either they didn't have calculator during the lecture when I give them lecture, or they didn't practice enough. That during the quiz they asked me a very silly question, Thomas, how to use calculator? Like when I asked them what is 13 factorial, for example, right? They asked me that question, Thomas, can you tell me how to use calculator? Well, and then I stare at them, I say, that's my question to you. You know, so when I ask you 13 factorial, I know you will use calculator. Okay, I expect you to use calculator. Now you ask me how to use calculator. That's the question I asked you to do. And then they say, well, I forgot. Well, that's my question. Do you remember? Okay, so in other words, even though using calculator will make it easier, at the same time, you still need to know how to use your calculator. Okay, that's not something I will tell you how to use during your test, especially. Okay, during your test, especially, you need to know how to use your calculator. That's for factorial. So you need to know what it means. This is what it means. And how to use calculator. Okay, so pay attention, not only for factorial, for any time I use calculator, you need to pay attention to those things. Now, the second part is, do I use capital A or lowercase t? So the second part is permutation. Now, the notation form of permutation is N, P, R, where the N and the R are subscript. Okay. They are subscript. So if I enlarge the writing, when I enlarge the writing, the P is capital P. The N not only lowercase, not like this, not like this, no, 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 not like that. It's lowercase and subscript. Okay, so not only smaller size, but it's also lower. Okay, that's the notation for permutation. Now, some notes. In other country, in other countries, they use this notation here, N, E, R. So the N were superscript, like exponent thingy, superscript, and the R here is subscript. Now, the thing is, I will not accept this notation. Uh, I will not accept this notation because it actually creates some misunderstanding, as if this n here is an exponent. If you write it next to another number, let's say, if I have 23 next to it, right? So there have been cases where people misunderstood this n as part of 23, while it's supposed to be part of the permutation notation. Okay, so we will not use this notation. Okay, we will not use this notation. Now, I'm not really a big fan of American way of writing things, but there are some reasons why they changed this to our way of writing. Okay, so please don't use this notation. Now, NPR means n permutes R means n factorial over R factorial n minus R factorial. Give me a second. I'm sorry. I'm sorry. I make a mistake. I make a mistake. Not supposed to have R factorial here. That's for combinations. Yeah, good thing I stepped back a little bit. That's what it means to be permutations. For example, let's say we have 5 permutes 3. That will be 5 factorial over 5 minus 3 factorial, which is 5 factorial over 2 factorial. Now this is equal to, if I write it out, this is 5 times 4 times 3 times 2 times 1 over 2 times 1. Now notice that the 2 factorial, 2 times 1 gets cancelled. Okay, so we get only 5 times 4 times 3, which is 60. Now, of course, if the number is small, I can teach you how to see the shortcut. For example, here we have 5 permutes 3, which means you will see that we start from 5. Okay, and then these 3 here represent the number of factors. That represent 3 factors. 3 factors going down. So for example, if I have 7 permutes 4, you can do this long way here. You can do this long way. Okay, you can do that long way. But I hope you will end up seeing that what you need to compute is actually starting from 7, going down, so that you get going down one by one, up to 4 factors. So 7 times 6 times 5 times 4. Okay. 7 times 6 times 5 times 4. It's just happened that we start from 7. It just happened that we have this 4 here, not because we end at 4. No, not because we end at 4, but because we have 4 factors here.
So that's only with small numbers?
Yeah, for small numbers, this is what we will do. What will that be? I think it's 840 now. 120 times 7, yeah, 840. Let's say another one, if I have 15 permutes 2. Now it means I start from 15 going down times 14 only. I start from 15 with 2 factors. Okay, so that will be 210. Yeah, for small numbers, you can do this. Of course, you can always use calculator. Okay, you can always use calculator. I just think sometimes when the number is small, it takes you a longer time to use calculator. Okay, now suppose I have, let's do the big one right now. 20 permute 4. Now this is supposed to be 20 times 19 times 18 times 17, right? Start from 20, 4 factors down. But this is hard to do by hand. This is hard to do by hand. Hard to compute by hand. So how to use calculator? We'll punch 20 first, and then go to the same section, math, PRB, NPR. Now our calculator cannot do, cannot type subscript. So the way they type it on their calculator, the way they write it on their calculator is lowercase, capital letter, and then lowercase. But when we do handwriting, the N and the R are supposed to be subscript. Okay, now after that, you type the 4 and then enter. Let's practice with our calculator. Okay, let's see. What's that again? 20, huh? 20 math, PRB, and then NPR, 4, enter. Okay, let me do it again. 20, and then I need to get the NPR, math, PRB, NPR, and then 4, and then enter. Okay, 116,280. So this is 116,280. Okay, now you practice. I would like you to try about 30 permutes 3, and then 25 permutes 6. Okay, you try. So 30 permutes 3. Let's see. Okay, do it with your calculator. 30 math, PRB, NPR, 3, 2. 24,360. 24,360, and let me write it down here. 24. And then 25 P6. 25 permutes 6. Ooh, that's a big number. Okay, 127,500,000. 125 billion. Oh, 127,500,000. 7,512,000. Okay. Now, that's for permutation. Now, let's see combination. Combination has a very similar notation, except we change the P becomes C. NCR. Okay, now this notation NCR also have other variations. In pre-calculus textbooks. They use this notation: parentheses, N on the top, R at the bottom, but no line in between. No line. No, not a fraction. This is not a fraction. No line. Okay, no line. And this means n factorial over r factorial n minus r factorial. That's what it means. Okay, that's what it means. Now, I saw a student from other country, I believe. The reason I say that other country, because even in Indonesia, when I learned it myself, we use this notation in other countries. In Indonesia, and I believe in some Middle East and some European country use this notation. NCR, just like the one NPR earlier, like the N is on the top left. Okay. In Indonesia, when I learned it, we learn it this way. Yeah, we learn it this way too. But right now, this notation is already being changed. Now, I don't know about other countries, but in Indonesia, they don't use this notation anymore. Yeah, they don't use this notation anymore. For the same reason, we didn't use that NPR where the N on the top left, because this may be misunderstood as an exponent for the numbers prior to that. Okay, so we don't use this notation anymore. Don't use this notation. So the person who used this notation in your test one, I didn't teach you this method yet, so I forgive you. Okay, but next time when you write this combination for that person, I need you to write it either this way or this way. Preferably this one. In this class. Okay, why? Because that's the notation you use for your calculator. Okay, now, what does this NCR means? For example, if I have 5 combination formula-wise, that will be 5 factorial over 2 factorial, 5 minus 2 factorial, which is 5 times 4 times 3 times 2 times 1 over 2 factorial 2 times 1, and then 5 minus 2 is 3, factorial is 3 times 1. Now you will see, just like in permutation, part of that will cancel. This will cancel. Okay, this will cancel. So we are left with 5 times 4 over 2 times 1. Now, notice that 5 times 4 is basically this 5 here, starting from 5, okay? And this 2 is the 2 factors. The 2 is the 2 factors. Let me use this color. This is 2 factors. So you will see the numerators actually from the permutation, but you divide further by 2 factorial in this case. Maybe I say 2 factors. Okay, so it's the 2 factors. The 2 factors. Now, of course, to compute that in this case, small numbers is easy. That's 10. Right? Let's try more. You can do it long way, but this time I teach you how to do it short way by hand. So 7 combination 3 means on the top will be the permutation part. 7 times 6 times 5. Start from 7. Start from 7. 3 factors. Okay, divided by 3 factorial. 3 times 2 times 1. Okay, notice that 3 times 2 times 1 is 6, can cancel with one of the factor at the top. We get 35. Now, how about, let's say, 10 combination 3? That will be maybe 10 combination 4. We board with 3. 10 combination 4. That will be 10 times 9 times 8 times 7 over 4 times 3 times 2 times 1. So notice that I can cancel this 8 with 4 times 2. And I can cancel that 9 with the 3 also. I have 3 extra. Okay, so I end up with 10 times 3 times 7, 210. Okay, that's if the number small. And when I say number small, I mean that this part here is not too big, but this one is small. Okay, if the number gets larger, then use your calculator. Okay, for example, if I have a 26, oh, I think that would be quite big. This is hard to do by hand. This is hard to compute by hand. Then let's use calculator. That will be press 20 first, and then math, PRB, and CR. And then 6, and then enter. Okay, let's see our calculator. 20 math, PRB for probability, and then NCR, the third option. We get 38,760. So 20, 6 is equal to 38,760. Now you see that this factorial, permutation, and combination falls into the same category in our calculator, right? Falls into the same category in our calculator, which is math, math, PRB, and then factorial, NCR, and PR, such that, remember I told you that I have some cases where students ask me during the quiz how to use their calculator. I knew it right away. They didn't practice at all, because if they practice enough number of factorial, enough number of permutation, enough number of combination by calculator, then they should have memorized them. Okay, it must be because they don't practice at all. Now, mind you that that was a once a week class at East LA College every Fridays, only 4 hours, such that some of them actually didn't study until Thursday evening. And on Thursday evening, without studying any day prior to that from the previous lecture, of course, they memorize near nothing. Imagine the class was like Friday class, they don't study anything after the class. And then Saturday, they don't study. Sunday, they don't study. Monday, they don't study. Tuesday, they don't study. Wednesday, they don't study. Thursday, they don't study until evening. They think they are so good. They think these students think that they are so smart. Actually, don't go too far. You won't be smart if you are not wise. Okay, and it is possible you can be smart without being wise, but the fact that you don't study for 6 days back to back and expect that you can memorize things without seeing that at all for 6 days, that's naive, that's arrogant, that's overconfidence. Okay, and then on Friday morning when they have the quiz, they ask me that question. I really want to say to them, got you. I told you, study. Okay. No, it's like this though. Of course, I'm not happy. I'm not that happy if my students not doing well. But at the same times, with my, if you see that I've been teaching for 13 years full time and 7 years part time. A total of 24 years, including my teaching in Indonesia. With this long period of teaching with so many students that I see being successful and being not successful, I can tell you one thing. If you want to be successful, you need to have at least one ingredient in your character. That's called dedication. That's called time management. That's called apply yourself. That's called humble to study. Okay, you need to have this. You need to have this though to be successful. Not only in my class, in other classes. And among these, actually, dedication, you need to really commit yourself. But the one hardest, actually, one of the hardest one is actually time management. If you don't manage your time, then you will always lose to those who manage their time. Okay? Time management is part of managing yourself. If you cannot manage yourself, if you can't even manage your time, who the peep are you to tell other people how to do things? If you cannot even manage yourself, forget being manager. If you cannot manage your time, don't expect to manage other people's time. okay? For you to be able to tell other people what to do, you need to first know how to tell yourself what to do, okay? Now, if you don't have time management, trust me, for the rest of your life, somebody will tell you how to manage your time. Okay? It means you will always be at the lower level of employment. And that's not the reason I teach you this class here. Okay? I want you to rise above. Be better than other people. We don't need to see this as competition, but believe it or not, when you go to work life, more or less, it's a competition. Now, of course, we don't compete by making other people look worse, okay? But we compete by making ourselves look better. Okay? Rise above the rest, not by pushing other people lower, worse, but you make yourself a lot better. And one of them is really your dedication, time management, apply yourself before you can apply what you learn. And you need to be humble to study. Stop telling yourself, I know this thing. I'm smart enough to study this. No, no. Trust me, those smart people, they always start with, what can I learn, instead of what I don't need to learn. Okay? So please, 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 those questions that they asked me during their quiz tells me a lot more about what they did and who they are more than the question they asked me. Okay, so to summarize this for now, you need to know how to punch n factorial, what it means and how to use calculator. You need to know NPR for permutation, and you need to know NCR. Okay, NPR and CR are very similar when it comes to the calculator notation, the calculator punch, how you compute that by calculator. So I don't give example for NCR anymore. Okay, now this n factorial, n permutes R, and n combination R are just tools that relates to your calculator. Now, counting techniques itself, counting technique consists of three big parts. Consists of three big parts. The first one is called fundamental principle of counting. It has other names, fundamental theory of accounting, or simply counting principle, or counting theorem, I think. Okay, it has other different names, but this is the first one, and that's why we call it fundamental principle of counting. Second is permutation. And the last one is combination. If what we have above here are the notation and how to use calculator, then what we have here are conceptual tools we use to do some basic countings. And I say basics because in long run, you will see we may encounter a situation where I need to combine permutation and combination, and then after that I combine with fundamental principle of counting. Okay, it gets more complicated later on. Okay, so these three tools that we have here, counting principle, permutation, and combination, should be considered as tools instead of category how to compute it. No, those are the tools. Okay, at the beginning you can ask, at the beginning when we have questions, we can ask ourselves, is this counting principle, is this permutation, or is this combination? At the beginning, But the further we go advanced, the further we go into the topic, you will see that it's more about what to do and how to do it, therefore which method I use. Okay, now let's see. To explain each one of them, I will use 4 steps method so that you can see the situation. What is the situation? And then what do we do, the action? What is being questioned? And what's the solution? What's the background? What we do? What is being questioned? And what's the answer? Okay, those are the 4 steps we will do. Counting principle, what is the situation? You have 2 categories, let me call it 2 boxes, 2 categories. Box 1 has M items. Box 2 has N items. Let's say, for example, next week I do, let's say, for example, I have a group or a category or a box or 3 pencils. Let's call this box 1. And the second box, the second category, let's say I have 4 erasers. That's the situation. Then what do we do? The action. Select. I'm sorry. Select 1 item from each box. Here's my phone. 1 item from each box. So what we will do, we will select 1 item from here, and we will select 1 item from here. Okay, now the question is, how many different pairs possible? Or if you have 3 boxes, that's how many triplets, how many groups possible? And the answer, the solution, it will be M times N. In this case, in this example here, the number of pairs possible will be 3 times 4 equals to 12 possible pairs. Okay, now we can use some tree diagram to help us visualize this. Suppose I have 3 pencils, call this pencil 1, pencil 2, pencil 3. Okay, so the first choice you make, you either get pencil 1 or pencil 2 or pencil 3 from the first box, and then for each pencil you selected, you go to box number 2, you have the option of selecting eraser 1, eraser 2, eraser 3, eraser 4. Likewise, for if you have selected pencil 2 from the first box, you have eraser 1, eraser 2, eraser 3, eraser 4 in your second selection from the second box. Likewise, for if you had selected pencil 3 from the first box. So you see you have a total of 12 pairs, right? So you either this pair, pencil 1, eraser 1, pencil 2, pencil 1, eraser 2, pencil 1, eraser 3, pencil 1, eraser 4, pencil 2, eraser 1, pencil 2, eraser 2, pencil 2, eraser 3, pencil 2, eraser 4, or pencil 3, eraser 1, pencil 3, eraser 2, pencil 3, eraser 3, pencil 3, eraser 4. So if you count it, you have a total of 3 times 4 possible groups. Okay, in this case, possible pairs. Okay, so you see that the situation is we start from many boxes, more than one box, many boxes, and from each box you need to select one item. From each box you need to select one item. So you get one from here, you get one from here. Okay, so then how many pairs you have, how many choices of how many different pairs you possibly have, and it will be, in this case, 3 times 4. Okay, now let's do some other similar examples. Even though I say similar, but the question may look very different. The question may look very different. Suppose, for example, another example, let me mute everybody. Suppose, for example, we have, let's say password. Let's say a password. Password with 4 characters. Four letters. Suppose I say create a password with 4 letters. Then how many passwords with 4 letters can be created? The answer is as the following. You have 4 letters, right? Okay, you have 4 letters, 4 spaces, 4 groups to select from. Okay, now the first letter, the first place here, how many letters you can select from to be a letter, the first letter of your password? That's 26, that's right. Then for every choice you make there, how many letters you have to choose from for your second letter in your password? That will still be 26, right? Thomas, it doesn't say that we can repeat or not. Well, because it doesn't say we can repeat or not, then assume we can repeat it. Because if I cannot repeat it, the question is supposed to say it, right? Okay, yeah. And then the third place, you also have 26. The fourth place, you have 26. So if you visualize that, you actually have this. The first letter, the second letter, the third letter, the fourth letter. Each one of, if one of these box has 26 possible options, then how many passwords you can get if you need to select one letter from here, one letter from here, one letter from here, one letter from here. That's basically the situation we have in our first example. Okay, that's the situation we have in our first example. Now, notice that my example in example 1 is totally different from my example in my example 2. Okay, in example 1, we use pencil and erasers, and then in example 2, we talk about passwords. Okay, but the underlying concepts of what we start with, what we need to do, and what is being in question tells us we need to use counting principle. Okay, now if I ask you this kind of question in my test, I require you to answer this way. I need you to write it this way: 26 times 26 times 26 times 26. Or if you happen to see it in advance, you can write 26 to the fourth first, and then you write the answer from calculator. Okay, I don't want you to give me the answer from calculator right away. Okay, if you give me answer from calculator right away, I will just circle it and I will say how. I penalize you all the points except 1 point. So if this question has 4 points, I will give you only 1 point. If you don't show me any work, you just show me the final answer. And the work I want you to show me, not a long work, I just need you to show me this or this. Okay, because what you write here in yellow tells me how you think.
Professor,
Okay?
quick question.
Uh-huh.
The little tree diagram you got on top,
Uh-huh.
the P3 and all that, will
Uh-huh.
you ever ask us to illustrate that?
I usually don't. I think I never ask that because this question is too easy to visualize, just 3 by 4, right? Okay.
Mhm.
And in reality, we have more than just 3 by 4. Let's say 300 by 400, but 300 by 400 3 will be too hard to draw,
Okay.
right? So either it's too easy or it's too hard to draw. That's why I never asked it.
Okay, thank you.
Okay, yeah. But these 3 actually help us to visualize that though. Okay, yeah, help us to visualize. So imagine if I ask you to do the 3 diagram for this. Trust me, you will spend more time in drawing the 3 than writing this, right? So there's no need for us to draw the 3 though. But you can use that 3 diagram to visualize. Okay. Now suppose I change the question from part A. We still deal with this password with 4 letters. We can change that to how many passwords with 4 letters can be created if no repetition allowed. Suppose you can, so basically you cannot use the same, any same letter. If no repetition allowed.
So it'd be 26 times 25 times 24 times 23.
That's correct. So that's 26 times 25 times 24 times 23. You can do it that way. Which, if you think about it, this is the same tool. This is the same to 26 permutes 4. Right? Okay. That's 26 permutes 4. But you can just compute that using the red color here. So you write this first, and then you use your calculator compute. Okay, but definitely you need to write this first before you get the calculator result. Okay, let's go a bit further. Suppose how many password with 4 letters can be created if it starts with a vowel. The thing is, how many vowels we have? In our alphabet, we have 5 vowels. Okay, and is repetition allowed? They don't say it, so assume yes. Okay, because no repetition is a restriction. If they don't say no repetition, basically it means no restriction. Okay, so because it doesn't say no repetition allowed or not, then we assume repetition is allowed. Therefore, whatever vowel you used earlier, you can use it again. Okay, so you write this first. This is what I meant by your work. And then you use your calculator to compute it. Okay, now notice that I use passwords here. You can change this into, for example, a 4-digit PIN. PIN with 4 digits. And how many pins with 4 digits can be created? How many pins with 4 digits can be created if no repetition allowed? And how many pins with 4 digits can be created if it starts with a prime number, let's say. Okay. We have a lot more though. Those kind of questions. In the last example, why do you only have 26 3 times? Well, because the first letter has to be a vowel. So the first choice, we have only 5 vowels to choose from, and then we have 3 letters left, right? So we have 4 letters for our password, right? The first one I have 5 choices. The second one I have 26. The third one I have 26 choices. The last one I have 26 choices. Okay. Good. Now, and that's for combinations. Our textbook actually has some word problems on these combinations here. Let's say number. My textbook, I couldn't use the 4th edition. You use the 5th edition, so my numbering may be different. So let's say, for example, it says here. Let's use this one, the easy one first, clothing option. A woman has, I get this question from the textbook, from our textbook, the 4th edition, while the one we have is the 5th edition. A woman have 5 blouses and 3 skirts. Assuming that they all match, how many different outfits can she wear? That's the question. So she needs to wear a blouse, she needs to wear a skirt, right? And so basically, she chooses one from the blouses. How many choices she has for blouses? She has 5 choices. And for every choice she made for the blouse, she has 3 skirts to choose from for skirt. So she has a total of 15 outfits. Okay, so notice that I start from what? Pencil and eraser, and then goes to password, now goes to outfits. Okay, so you see we have different applications, but the underlying concepts are the same. Actually, for this clothing option, I would like to ask one further question. Let's call this a follow-up question. Something to think of during your break. Follow-up. If she has a choice of buying or basically increase blues or a skirt, which option or which decision will be better in increasing her options more? Okay, right now it's 9:09. We come back at 9, let's say 9:10. So let's say 9:20. We come back at 9:20. A little break for me, for you too, of course. Okay, let's start again. To answer this question, let's see. Suppose we buy blues. Suppose the option is buy blues. Then it becomes 6 times 3, which is 18 outfits. And if she bought skirt instead, it becomes 5 times 4 outfits. So in this case, purchasing or buying skirt is better. I like to see this question in our problem set because actually this is a real life question. I have this issue. I myself have this issue. When I start teaching at Cal LA in year 2000, I'm sorry, the year 2001. In year 2001, I was very, very poor. I came to the United States at the very end of 1999. So I can say January the 1st, year 2000, I was here. And in 2001 or 2002, no, I got it wrong. 2001, I got the offer. Then 2002, January, I started teaching at Casa LA. And at that time, my situation was as the following. At Casa LA, at that time, they still have quarter system. At that time, right now, I believe they already changed to semester system. They have quarter system, 10 weeks. Which means we will meet the students 10 times 2, twice a week, plus 1 final day. So we will meet the students 20 times. And at that time I was so poor, so I did have that inferiority complex. I feel that I'm so poor and I don't want to show other people that I was poor. And I have 6 blues t-shirt. I cannot call it blues, huh? In Indonesia we call it blues anyway. Call it t-shirt. So it sounds, as I know, blues in America means for ladies. Okay, so 6 t-shirts and 3 jeans, 3 pairs of jeans. Now it gives me 18 possible outfits. Right? Of course, with that situation, I was thinking, oh, shoot, you know what? If I have only 18 outfits while I need to meet my students 21 times, I was so afraid that a student will one day pick up, oh, you wear this pair before. You wore this pair of t-shirt and jeans someday in the past. And for me, at that time, that's embarrassing. Okay. Now, of course, right now I don't feel embarrassed anymore. In fact, I have the same. I have some of my T-shirts actually double or even triple. Like for example, my Reebok sweatshirt. I have 3 of them, 3 exactly the same one, 3 exactly the same one. One time I lost it, and a student actually claimed that to be his, and I say no, that's mine because I have 2 more, and this is what I wear. I left that in the classroom. Anyway, yeah. Right now, I don't have that issue anymore. I think after we live, the good thing about living in America, I think, is that we care of ourselves more than what other people say about us. It's quite different from Indonesia, where people gossip about each other. Okay, so when I first came to the United States in that January 2002, I have that in mind, that what happened if other student, what if other people say this and that about what I look, what I wear, you know, while actually right now, the way I think is like, I don't care what people say about me, as long as it is reasonable, it's clean, it's not smelly, okay? Who cares if I wear the same thing for 6 months? I won't be that crazy, but even if I were that crazy, what the heck, right? Okay, it's what I wear, what it has to do with you. You don't like to see me, don't see me. Okay, in fact, for some people, you need to pay to see that person, right? Okay, so at that time, I have this situation. Now, the 10 weeks implies that's more than 2 months. So after the first month, I decide I need to buy something to increase my number of outfits. So which decision is better? Should I buy t-shirt? Should I buy t-shirt or jeans? So if I buy t-shirt, then I will have 7 times 3, which is 21. If I purchase jeans instead, I will get 6 times 4, which is 24. Of course, then yes, it's better to buy a jeans, right? Okay, so I have 24 possible outfits. So beside these 21 times coming to school and appear the same and appear different in front of my students, I have 24 days actually to come to school, even for my colleagues, right? Let's say some other days I need to come because I forget something in my office at school, you know, okay? So of course, to be honest with you, what I end up buying was a green pair of jeans. So the color is green, and I just don't like it. I hate it so much. Yeah, well, that's my first purchase. You know, it comes from a situation where I felt inferior, and turns out to be something not necessary in America. You know, in Indonesia, they still look at that a lot, though. In Indonesia, uh, people see what you drive. People see how big your house. In America, we see how, so when it talks about car, right? This is for statistic. This is to help you to see statistic from different cultures. From car's point of view, okay? The reason I share this with you so that you realize that the measure or the judgment you make in America using American culture as your glasses, you look through American culture, is different from the way things being seen in other countries. So in Indonesia, for example, okay, you are at a higher class if you can drive a BMW compared to if you drive a Toyota. Yeah, BMW clearly more expensive than regular Toyota. The regular BMW is more expensive than regular Toyota. So if you drive BMW, people look up to you more than if you drive Toyota. Now you notice that in the United States, that's not the case, right? Nobody cares what you drive. Just drive right, okay? Just drive right, okay? In fact, for me, I myself, okay, I'm not applying that to anyone. For me, I look up to that person from what is the MPG for that car. I drive a Prius. Okay, the only car that have better, I think there are some cars right now, but the big one, the only car that is better in MPG than Prius, maybe Tesla. Okay, so if you say, Thomas, you know what, we need to believe that climate change is happening, then I will ask you first, what car do you drive? If you drive a gasoline car, you know what, you don't walk the talk. Okay, you talk too much, but you don't actually apply that. If you really believe that climate change is happening, start with your own car. Okay. That's so me though. That's so me. The one I explained earlier is your outlook, like outfit. Now in Indonesia, it's more about, for example, what brand you wear in Indonesia, and I think some other Asian countries also have this mindset. Now in United States, do you believe people look at your outfit from what it says? You know, so for example, people will look at what you wear if you actually supporting a certain cause. For example, uh, for example, wear a mask. Imagine if your T-shirt has this writing. People will look at that and say something. It will attract more attention of what it says on your T-shirt compared to what's the brand. But back in Indonesia, people don't care what it says. As long as people care more about what's the brand of your shirt. Okay, if your shirt has brand XYZ, people may look down on you compared to if you wear the brand Coach. You know, that's strange, huh? Yeah, it's a different point of view. Another issue that it's kind of we need to be aware with the difference of cultures, difference of situation is the wage. Now in America, we want to have $15 per hour pay. That's in America, okay, which is a good thing. Okay, I am actually supporting higher wage for everyone. Okay, for everyone. The higher the better. Okay, I have my own reason for that. But do you realize that back in Indonesia, and as I know also in China, for example, in Indonesia, the fact that you can get $3 per day is something good. And when I say $3 per day, it may refer to 10 hours per that day. The notion of employees in America is that when you work for me, I get your whole life for this 1 month. So I can call you 3 o'clock in the morning to do something. Okay, in America, that's a big no-no. In America, I go to, let's say I go do office work. I go in at 8 o'clock. I need to have my 1 hour break. I get home at 5 o'clock. Once I clock out, you're not, I'm not yours. But back in Indonesia, your boss may call you 3 o'clock in the morning to do something, and you just lose the sleep. That's culture, though. That's culture. That's why then, believe it or not, people from Indonesia, when they come to United States to work, they may seem to be a lot more dedicated. Okay? A lot more dedicated. But that's actually not because they themselves is dedicated. They get used to that mindset that once somebody pay me the salary, then my whole time basically belong to that person. That's why for in Indonesian culture, it's kind of strange for them, I should say for me too, when I first came, it's kind of strange when somebody say that person have 2 jobs. While in America, having 2 jobs is actually quite common, especially if you are middle class or lower. Right? It's actually makes sense. One job may not be enough because each one of them part-time job. But in Indonesia, when somebody say, "Oh, I work 2 jobs," that person will say, "Then what happened if both of your bosses actually call you to do something?" They don't have the mindset that, well, I work from 8 to 5, and then from 6 to 2 o'clock in the morning. They don't have that mindset. In America, it's possible. Or we can do part-time from 8 to 12, and then 1 o'clock to 4 o'clock, right? But back in Indonesia, no, that's not the case. That's not the case. We don't talk about like hourly salary. There we talk about monthly salary. So I pay you per month. I can call you anytime. That's, by the way, I'm just trying to explain to you the different, the cultural difference. So be a bit careful when you read news from internet when they compare, for example, the pay in Indonesia or other country with America. Okay, basically, be very careful when we judge other culture from our cultural glasses. You know. Okay, so let's say this is Thomas, right? I live long enough in America. So my glasses here, the way I see things, I already use American culture. To see people in Indonesia. So if let me tell you this, when I was a graduate student, I make around $2,000 per month because as a graduate student, I also teach. My brother at that time working as the manager of a big company in Indonesia, as big as Ralph's. Okay, and he worked as an IT manager for the corporate. So he didn't work for one branch. No, he was actually at the headquarters. Okay, and he was the IT manager. He made $900 per month as an IT manager. IT manager in Indonesia make approximately $900 per month. And I was a TA only. I make $2,000 per month. Now, of course, if I use American culture to see his pay, I say, well, your position is actually a lot higher than me. As a TA, I only oversees like around 40 students. As IT managers, you actually oversees around 1,000 people, 1,000 employees. But your pay is less than half than mine. Yeah. But the thing is, the cost of living in Indonesia is a lot cheaper compared to here. So I cannot compare these numbers just like that. No, I can't. You know, that's abuse of statistic. Okay, that's abuse of statistic. $2,000 at that time in America is barely enough for my food and for my rent and for my gas and for my cell phone for me myself. For him, $900 is actually enough for him to pay for his mortgage with a family, with food, with cell phones for him and his wife, and education for his children. Okay, by the way, in Indonesia, you need to pay for uh, your school. Not like here, like when you go to high school, as I know you don't pay or you pay very little, right? But in Indonesia, you need to pay. Okay? Now, $900 is enough for him, for his family, and $2,000 is barely enough for me myself. So while I say that I get higher pay than him, that $2,000 is barely enough. So I think if we have a discussion about increasing wage, which again I said earlier that I fully support that, we also need to pay attention about uh, the cost of living. That's way too much, in my opinion, compared to other countries. Okay, so it is not fair for us to compare our wage to some European country only, while we don't compare the cost of living to some other country. Okay. Well, anyway, that's some background from me. Okay, I was a poor person before in 2002, very poor, but education makes me a lot better. And I hope you have the same feel, the same reason you come back to school. For what reason? The reason you come back to school to have better education, you need to learn something. Okay, you need to learn something such that later on when you apply for a job, people will not just look at your diploma, but they also see what skill you actually have. Okay, more and more companies actually testing you when you apply for the job instead of trusting the diploma you have, because of the great inflation is way too widespread. Okay, let me show you something. Let me show you something. Long time you don't see my face. Let me show you my face. I hope you don't mind me showing you my face. I want to show you something that, can you guess how much I make annually? Anybody? Can anybody guess how much I make annually? 80,000. Somebody say 80,000. Any other guess? Is 80,000 a good pay? 90K. Oh, that's even better. Would you like to have 90,000 pay annually? 84K. Great. Wait, that's lower. Somebody say 120K. Great. Yeah, I love it. Would you like to have 120,000 annual pay? That's actually 10,000 per month, huh? If we have 120,000 a year, right? That's around on average. That's 10,000. Is it a good one? Yeah. Our friend Robert say yes. It's a good pay. Let me show you my pay. Let me show you my pay. Now I'm showing this not to brag about my pay. What I want to show you is because of education, I get a much better life. You go to Transparent, California, and you can get the pay of every public employee in California. You can type Thomas Arjun. This is my pay in 2008. You see that? What is my regular pay? Can you see that? Anybody say holy moly or holy cow? Professor, I have some bills that need paying. Don't worry, me too. I have a wife and 2 children and parents and in-laws. Okay. Yes, I get better pay. In fact, let me show you more. That's not just one time. That's not just one-time pay in 2008. Let me go to transparentcalifornia.com first. So yes, anybody, not just me, anybody. You can type the governor's name here and it will show you how much pay he got. This is my regular pay in 2008. Okay, and this is my health benefit. Of course, this health benefit will not come to my pocket. Okay, and 162,000 regular pay, you need to subtract that by approximately 40%. So I get approximately only half of this, 80,000. Yeah, because the other half will go to, approximately the other half will go to my federal tax, and then state tax, and then city tax, and then union fee. Good thing they take away the health benefit already. So this cannot be counted as my regular pay. Now, the thing is, besides working at LACCD, West LA College and East LA College, I also work part-time at Santa Monica College. So at Santa Monica College, I also make some money. Okay, I also work there. So yes, in total, concluding all the benefit that I received through my health insurance, life insurance, and the health insurance actually covered my whole family. Once my daughter was born in January, she got covered right away. So a total of approximately 250,000. Now, telling you this, do you want to make what I make? Do you want to be like me? Yeah. We must also keep in mind that you have taught a long time. Actually, one of our friends say that. Are you advertising teaching? Okay, I'm not just advertising teaching. And yes, I have taught a long time. And that every year my salary increase by approximately, as I know, 3% because my union fight for me. Okay, and also because I have taken a lot of classes, passed a lot of classes to be more precise, and I have equivalent of 3 masters, and I can say I finished 2 years of my PhD. I don't have PhD though, so don't call me doctor. Okay, I don't have PhD. All of those pile up together. Now I enjoy such a pay. So it is true that I have taught a long time, but if I didn't take a lot of classes in the past, and if I don't maintain keeping my job of dedicating myself to teaching, I won't stay long enough in this field. In fact, to be honest with you, you really need to have that passion to teach. The purpose of me getting that kind of pay so that I can focus on teaching instead of worrying about money. Okay, so I want my students, you, okay, to start shaping yourself to the point that regardless who get elected as our president, regardless who get elected to our Senate, regardless who get elected to the Congress in general, regardless who is our governor, regardless what's the economic situation, you can adjust and be safe and financially secure in any situation. That's what I want you to be, and that's what I'm teaching you this all right now. Okay, I want you to be in that situation that you can survive whoever in charge in our government, whatever the financial situation of the world. Okay, of course that's not easy. I'm not saying it's easy. No, it's not easy. You don't know how much I actually push myself, dedicate myself to be in my situation right now. Okay, I usually say that in the past I was so skinny. In the past I was so skinny, and I say that I was so skinny because I studied my ass off. Okay, I sleep less. Okay, now I have this situation. That's the payoff. Okay, that's why then I can put more in my bucket, on my plate, beside taking care of my family, of course. Then I can take care of my, well, to be more precise, I took care of my parents first. Don't forget, my dad had a cancer, right? Even though he survived, he's older right now, and I need to take care of them, right? Then once I believe I am financially secure, then of course, then I can date somebody and get married, right? And once I feel even more secure, then I have children, right? Okay. And right now I'm paying for my house. Uh, I'm going to a good direction, right? Now I know of some of you, if not a lot of you, are not in the situation I have right now. But hang in there, okay? When I was at your age, I may be even worse than you. Okay, telling you this not about bragging about my situation, no. I'm trying to show you that you can be a lot better if you do the right thing. Okay, I hope that's a word of encouragement though. Okay, don't give up on yourself. No, no. However bad shape you are in right now, okay, pray hard, work hard, do your best, be wise, dedicate, dedicate yourself, right? Apply yourself, manage your time, do everything right. Once you are going to the right direction, it's just about time you arrive. Listen to this. Let me say it again. If you are in the right direction, it's just about time for you to arrive. If you are in the wrong direction, however much effort you spend, you won't arrive at the right place. Okay? And of course, I think I make a lot, at least in my opinion, compared to the poor guy who came to the United States 20 years ago, right? I make a lot more right now. And I remember when I was in that situation. So I also help my fellow citizens. I can tell you that at this point, I support 8 girls, kids to be more precise, but especially girls from 8 different countries, and I support them through work vision. Not a lot. I don't donate a lot. Only approximately $35 per person. And I purposely choose girls from these countries because in some countries, when you were born as a girl, they actually put you at the lowest class of the society of the people, and they have the least chance to survive to adult. And that's why I support these girls to provide them food, education, and healthcare. Beside these 8 children that I support, I also support 5 orphanages. I think I spelled it wrong. Now, I'm not saying that I support these orphanages and nobody else support each one of them. No, I donate a little bit, okay? Because I knew if my society, people around me didn't take care of me and my family when my dad had that cancer, I won't survive. So this is my way to give back and say thanks to God, say thanks to my society. Okay, and beside that, I also support 2, actually right now 3 plus 1, 2 in Indonesia and 1 in UC Riverside, the university students. That's what I do right now with that money. So why do I say this to you? Because I want you to be rich. And I hope you can be better than me, make a lot more money. Once you get rich, and actually you don't need to be super rich to start helping. The more you have, the more you can share, right? And it starts from one person that I support at World Vision. It starts from one. And the more I can, then I support more, I support more, I support more. Okay? I hope you too, one day. Okay? You very likely, the students at WLAC College, the student body we have at WLAC College, actually, a lot of us, a big portion of us actually financially weaker. And I want you to be rich. I want you to be successful in your life. You don't need to pass this class, okay? This is one way, but not the only way, okay? But one day when you get much more secure financially, please don't forget the rest of the society that needs your help, okay? I try to set an example to you. This is one thing one positive thing you can learn from me. One negative thing that you should not learn from me is gambling. Seriously, don't gamble. Okay. For me, gambling is a sin, but to be honest with you, I did it anyway in the past. I was defaulting. Well, anyway, I talked too much about this. And this is just part A, huh? Okay, let's go to part B. Part B is on permutation. The situation, you have one category, one box only with...
Professor,
Yes, sir.
we can't see the screen.
Oh, hold on. Which screen I am at?
Uh,
I'm so sorry. I'm
You're
so
okay.
sorry. Thank you, thank you, thank you. Thank you. Yeah, I was talking about this earlier. Oh, I'm sorry. I wrote so many things already. Anyway, uh, this is not part of the lesson. Yeah, next time please let me know. Okay, even earlier, but I was not aware of that. I get so carried away with my story. Permutation, we have one category only with n different items. So imagine if you have a box, let's say you have a box with, let's say with 5 letters, A, B, C, D, E. Okay, so a box with 5 letters, and then the action, select R items one by one. Order is important. The key is the order is important. So let's say from here, I want to select 2 letters from these 5 letters here. Okay, one by one. And of course, because I say 2 letters, I'm not selecting 1 letter twice. No, that's not what we do. We are selecting 2 letters. Okay, and then the question is, how many arrangements? The word arrangement implies the arrangement is important, implies the order is important. Sometimes they also use the word how many permutations are possible. Or how many orders are possible. Okay. But of course, there are possibly other words that they use to imply the order is important. Okay. And then the solution will be NPR. So suppose, going back to this example, this brief example here, suppose I have 5 letters A, B, C, D, E. I need to select 2 of them as my key pair. Okay, let's say my password. Okay, then how many possible arrangements, how many possible passwords that we can create from here? Then it will be 5 letters permutes 2. That's 5 times 4, then they are 20. Okay, now some notes, and this is a very, very helpful note. All permutation problem this is part B, right? Can be done using counting principle. Method. So for example, going back to this example here, instead of seeing that from permutation point of view, you can also say the following. Okay, I need 2 letters, right? I need 2 letters. How many letters I can choose from in my first choice? I have 5 choices, right? And then after I choose that 1 letter, I have only 4 left, right? And then how many letters I can choose from in my second pick? After I took the first letter out, then I have 4 choices in my second choice. Okay, so a total of 20 possible pair of letters. No, I should not say pairs, passwords. Okay, now that's 10 o'clock already, so I will stop here. My suggestion is, if you have a chance, please watch the lecture video I showed you earlier from page, the pages at the left-hand column here. But the one you watch should be, this one. Okay, I already put the link there for my videos at YouTube from East LA College. Okay, and suggested homework, let me go back here. Suggested homework from 5.5 will be from number 5 to number 47. 5.5a. We are not done yet. We are not done yet with this section. And we will finish this section 5.5 and 5.6 tomorrow. Okay, that's for today.